Hey, welcome. Today is August 7th, 2025. My name is Newman, and I am here with Harsha and Unspent and Lewis and Jason.
So we have four cappers: Newman, Jason, Unspent, and Lewis. And I'm
There we go.
Harsha, and I'm the Don for today. And we will be going through crowdfunding.ak, which is a validator created by Emergo Academy. Are you guys ready?
Let's do
Yeah.
All right,
Yes,
perfect.
God.
So
it.
before we get through this validator, I want to let you know that this is a validator that is written with a lot of holes in it, as in there are lots of problems with it, and they want us to identify those problems. Okay, so I will quickly go through the validator, and I want you guys to give me your opinions or where this validator doesn't work efficiently. Okay.
Love it.
Cool.
All right, perfect.
Okay,
So let's
boss.
let's jump in. So initially we have like a datum type they have defined, which has the campaign ID, title, goal, creator, backer, amount, deadline, and current funds. This is the datum. And then they defined an alias type called action, which is just an integer. And they use this alias type in the redeemer. They have defined another type for redeemer, and they use the action right here. And in the redeemer, they have the same thing: campaign ID, action, amount, and backer. Jumping into the validator is called manage campaign, and it's a spending validator. Okay. So let's jump into the logic. Immediately, they are saying expect some datum is equal to datum. So they're just unwrapping the datum from the option part in the spend. And if some datum is available, when the redeemer dot action, so they get the redeemer here, redeemer, so they haven't exactly specified the type of redeemer, but they're saying, hey, if redeemer dot action is 0, then cancel campaign. If it is 1, then support campaign. If it is 2, claim the funds, and everything else it fails. Okay. Now let's jump into these functions: cancel campaign, support campaign, and claims. Okay, so let's start with cancel campaign. So when redeemer.action is 0, that means it is cancel campaigns. So cancel campaigns. So cancel campaigns is a function that takes in datum of the type CF datum that we defined up there. It takes the campaign ID, and it takes the signatories, extra signatories section from the transaction, and it gives out a bool. And these are the conditions for it to pass. Datum.campaign should be equal to campaign ID. So this campaign ID is basically redeemer.campaign ID, by the way. So the campaign ID in datum and redeemer should match. That is one condition.
And the I guess it's not super important to know, but this was part of an Emergo tool, and that's why it's kind of built to spill. It's sort of there are some errors in this, and that I think the students were supposed to find them. But they do. The one thing that I want to point out is that it has like a different flow, like this whole online uh well, the commenting is interesting, and they have this actions enumerator in line 19. Uh the Instead of having an action that's written out, they've got this little code, and I don't quite understand that, why they don't have like a variable. They're just
Where would
choosing
they
to
use a variable?
uh they would just create an a type of action, like a redeemer type. Like, we don't do it that way. I guess that's all I'm saying, is that we would have just a
An int, right?
well, right
An
now
int.
it's just this int, yeah. But
Yeah, yeah, yeah.
typically we would just call it, claim dash funds support dash, claim support and cancel. You know what I mean?
So
Uh,
this is the same as this. Like, say for example, I can do this also. I'll put a constructor 0 here, and I'll do this, and I'll copy this in it.
okay.
You know,
Yeah.
and then again there'll be like a 1, and the same thing goes in, and 2, and the same thing goes in. So instead
I
of writing
see.
it so many times, they just okay,
Interesting. So they have basically two types
3 times.
there.
Uh,
Uh,
is this the same if we got rid of this action and we just did int?
Yeah,
Is that the
it'll be the
same?
same. It'll be the same. But
It's
they
just an
use
alias.
yeah, yeah,
So they're just calling an int an action.
yeah. It just explains better what's happening.
Yeah, it
huh.
depends.
Yeah,
You know.
because this action is nothing but these guys anyway. Action enumerator.
Yeah.
Ah, you're right.
It's just
Okay, so it's not any int. It's only one or 0, 1, 2. Okay, so then to me it does make sense
oh,
to actually name it
and
something
now
else because it's not any int. It is a specific action, and we have 3 of those choices.
Yeah,
Yeah. Okay,
which
that's cool.
tells me that we could validate on that. So like that, and I guess that's what it does down there in
yeah.
the
That's
validator,
that's
but
what's happening. Yeah,
yeah. Hmm.
Okay, so I don't see a problem yet. I mean, maybe we could do some type checking for the redeemer, but let's just assume that this works. This looks good to me. And so then as long as these are all returning booleans, we have like decent structure so far. And I'm just saying this out loud because right, apparently there's
Yeah,
bugs. So
we're looking for bugs, right? So
yeah.
well, yeah,
So those
yeah.
look good to me right there. This I don't love. I'd rather see a cleaner and statement. Like I don't like all these guys, but that's just personal preference. Datum.funds equals 0.
yeah.
I guess I don't understand exactly what's going on. Our datum dot funds. I don't think we have funds on our datum.
We don't have funds.
Current fund.
Goal. There is
Current funds, there
goal.
it is, the
Current
bottom.
fund is
Current
there,
funds. Current funds. Okay,
Current,
so we do. So current funds equals 0.
and datum
Um,
dot amount is 0.
yeah, so this is to cancel a campaign. So when you're canceling it, you just have to make sure that it's the right ID. The funds are 0, amount is 0. Basically, everything is like
There's no
null.
backers, and it must be signed by the guy
Who
who
created
is the
it?
creator, like the
And
creator of
then
the campaign.
this must be the extra
That is
signatories.
the extra signatories.
Yeah. Okay.
So that's what we have, and then you can cancel the campaign.
Okay.
Um,
What's the difference between the amount and the current funds?
Yeah, I don't know yet. I haven't seen either of them used.
yeah, I mean, the difference, I am not sure of the difference amount and current funds, but here is what I don't understand. So I'm assuming since this is a spending contract, there is one UTXO with initial values
Yeah.
of 00 of these values.
Yeah.
So if that UTXO is not spent and updated, that means you can cancel this campaign.
Okay. So you're going to put it into the validator with these initial settings of 0, 0, and the empty string, right?
Yes, yes.
And then so the idea is if that has not been updated, then all those values will be the default, and therefore we could still cancel it.
Correct.
Otherwise, we're going to be updating the values, is what you're insinuating.
Yes. That's what I think.
Yeah, I'm ready for the
Hmm.
next function myself.
Okay, so the
Okay.
next one is supporting a campaign. To support a campaign, it takes the datum, it takes the
Oh,
campaign ID, and it takes the extra signatories. And it is saying the campaign ID should be the same as the one in the Redeemer, and it must be signed by the guy who wants to donate. So
by
his
the
signature is being checked.
And well, must
And
be that must be signed by is a function, and I think it's down there on line 116. Is this the first time that we've run across must be signed by? No, no, no. We did it again in the can't in the next one. So that might be good. Let's look at that because I think that's like a little helper function that they just create.
must be signed by, is it a, they didn't import
I
it.
think it's in this. No, it's in here somewhere.
Oh,
It's
somewhere down here.
119, 119, 116,
Must be signed by, yeah. So it's
116.
just checking if the list has the signer or not. It's the same thing.
that's more annoying. That's
Yeah, what do
more
you think?
annoying. Just write list.has.
Um, yeah, that's true.
Look at that. I mean
Yeah.
that you take like 20 characters and you make it take 60.
Yeah,
Yeah.
I mean it reads better, but yeah, list does the trick.
Yeah, I guess right. If you've never read Aiken before, but at this point we know list.has is quite a normal thing for us. But
Right.
anyways, just semantics.
Yeah. So that is
So
one. Uh-huh.
who's the datum.backer and how does that so it
Yeah.
must be signed by the datum.backer, so that gets set when you initialize it. So when I first put the UTXO in there, I'm going to write a verification key hash on there. And so the idea is when you're supporting it, the backer has already been put on chain.
Yes. So
Who's the backer?
the
Where
backer.
are parties? Yeah, like you know
So
what I mean. Give me
there
like
are only two parties here.
okay,
One is the guy who started the campaign. That means he can withdraw the money from this campaign,
the
and the guy who
creator.
wants to support the campaign. And the guy who wants to support the campaign is the backer, and the guy who started the campaign is the creator.
Yeah. So, but when we're spending the support campaign, we already have the backers key
Right.
in Datum.
No, the backer puts it in there.
Datum.backer.
Oh.
The backer
Oh.
puts it in
Right.
there. Initially, it's empty. Remember, so for the cancel campaign, that's what they're checking. Datum.backer is like empty.
There are no backers.
Okay. Okay. So if it was empty, this would fail because must be signed by empty. Oh, actually, I don't know if that would fail, but let's just assume it would. Yeah, list.has, right? It would fail.
Yeah, I think initially it would fail because
Yeah, it would fail.
initially, uh,
So you need to put, is there
so
a function that adds
Yeah.
A
datum.backer in, or
backer.
no, that's just
Yeah.
off
Yeah. Yeah.
chain. You're
that's
just
off chain.
gonna
Yeah,
do that
that's off
in off
chain.
chain. And
So
there's
frankly, I just don't understand this support campaign because you don't actually have to spend anything to like be a backer. You just put in the correct datum and you send whatever amount and you make sure, yeah, so once you put in the correct datum
Ah.
and just send in like a UTXO, you should be able to back it, right? Like what's the point of doing another spend? You know, what's the point of spending? I don't understand. What's preventing you from just like having an off-chain UTXO that builds like the correct datum and directly send it to this address?
Okay. Does that make sense? I think that makes sense to me, meaning that there is no check on like funds being spent. Although look up at spend, look up at and what's the
yeah.
difference between support campaign and oh no 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 spend. See, these are all wait, stop.
Yeah.
Go to line 34.
Yeah.
Yeah. So the spend, and this is manage the campaign. And then look, we've got the redeemers with the like on line 30, 43 and 44. Oh, I can just use mine.
So my feeling is initially there is just like a UTXO with all of this as empty, and everyone that wants to support basically spends that UTXO and puts in a new UTXO with like updated datum. And there is only one UTXO in this campaign validator at all times. I mean, one
Right.
useful UTXO, otherwise it'll just be locked.
And all of the backers. So this stuff, yeah, line 8. Yeah, okay, yeah. And I
You
think
know,
that's a big thing. I mean, we could now I did notice the testing on this was really interesting. Like they don't test in this Aiken file. They have
I put
a
the tests in the Aiken file.
oh, you put them down in there. Look at
Yeah.
you. Okay. Okay. So they just had a different way of like importing the tests because all these tests and validators are just functions. You know, they can be imported and exported, uh, just like in code. I guess in any code language you can import and export the functions. And so Harsha's just pulled them
Yeah.
in here.
Yeah. So my one of my other things is, if there is only one UTXO here and you can spend that UTXO to put a new UTXO, what is stopping the backer from actually spending the UTXO and never putting a new one?
There's no checks. I haven't seen any checks
Yeah.
on tagging outputs or value or
Uh-huh.
anything. All I see
Yeah.
is signed by, and then a couple of these datum checks. So, right, and then I read the line, this contract is like Swiss cheese. Right? I don't know
Yeah.
where that is. It's somewhere in there. So,
It's
Yeah.
at the bottom.
Full of holes.
yeah. I would say the first big hole that I see is not tagging outputs, which is what you were just saying.
Mhm.
You can kind of do whatever you want as long as it's signed
Yeah, exactly.
by
So
the
that
right
means
person.
some random dude can come and just like take the funds, which is
And like, so I could, okay, right. If there's a UTXO in there and Harsha's verification key hash is the current backer, I could spend that UTXO, change that datum.backer to my own public key hash, and then at which point I could sponsor the
Yeah.
campaign. I could
Then
support
you
the
yeah.
would
So
be
campaign.
I can, so this is how, if I wanted to scam this campaign, what I do in this current validator is this: I would fund it for once so that I can change the datum, right?
yeah.
And then just claim all the funds.
Because
Yeah. I guess I don't know. I like you're saying, how can you hack it? I don't even know how to do it normally. Like I don't know what they're trying to do yet.
right.
To me, it seems like they're not doing anything, right? And maybe this is where the holes, the Swiss cheese comes in. It's like they're not really doing anything. They're just, and so then it's like, okay, well, you can hack it in a million ways, but like, I yeah, I wish I knew what we were trying to do better.
So wait a minute. Now this I think gets to a fundamental thing that I come into contact when I'm looking at these validators. Um, it's so important to get like the context or have it in my mind, like what it is doing.
Mhm.
For instance, in Asteria, they have the that design document where they have a visual representation of the transactions. Um, and sketching things out, I feel like that's like a fundamental programmer sort of step, is the whiteboard step where it's like, okay, we've got this data, we've got these functions, we've got these validators, these tests. I mean, tests come later, but you can they it's that brainstorming, forming the mental model, and once you get it on paper, and then you express it in code, and then you can punch holes in it, and then sometimes you go back to the paper, go back to the whiteboard, back to the drawing board, literally, um, and then figure things out. So when I approach a validator, I think that's an important step is to say, okay, what is it that we're trying to do? And that's just what Unspent was just expressing. Like what are, what's going on? And then that back and forth between the drawing board and the code would get us to a better spot.
I wrote this line the other day for not trying to explain what this is, and I wrote, it doesn't do anything. It only prevents certain actions from happening. Right, like that's all a smart contract is. Like it doesn't do anything on its own. It's UTXO. Like it has to be initiated. All it can do is prevent certain things.
Mm-hmm.
Um,
An
and
Aiken file doesn't do anything. It only prevents
Oh,
certain
now I
things from
kind of
happening.
get it. Now that you guys are saying that, maybe this whole thing is just to register the backers. So this UTXO will always have minimum ADA in it, but it'll just keep updating the datum and nothing else. So they're not actually putting in funds into this validator, as far as I can see.
Interesting.
So
Interesting.
now we know who owns the campaign, and then we also know who the backers are, and that's it.
but I can make it. I can change the datum.creator.
Backer.
I
Datum.backer.
think I can change all of it.
Is there a datum.creator?
Yeah.
And there's nothing that says it needs to be the
Ah.
same.
Yes, I agree.
Yeah.
I
Also,
agree.
And okay, Jason.
the bucker, should there be multiple bucker or just one bucker?
Yeah,
So
that's
I
what we don't
think
get.
that's right.
So
So when,
yeah, like that needs to be a list or something.
yeah, that's right. Otherwise,
So
it'll just be one backer for.
uh-huh.
But
Jason,
again,
I had that same thought. I'm glad you brought
we
that
don't
up.
know. I would almost rather throw this away and start with a fundamental goal of ours, and then create
Uh-huh.
a contract that accomplishes the goal.
Or what we can do is like, are you able to see my screen? So this is what they have. Maybe so their whole thing is this. So they have off chain, they have the validators, they have the README. Maybe we should just do a README, or this doesn't give much.
Yeah, that README wasn't very
Protocol
satisfying to
design
me.
V1MD. Maybe this will give us.
Oh, hell yeah, here we go.
So they're saying create a campaign. You need inputs, enough ADA to cover create campaign transaction fees and claim. Goal not reached. Transaction fee.
What the shit?
Enough ADA to cover create campaign transaction fee and claims.
Oh, and claims transaction fee, but when the claims are when the goal isn't reached, meaning that I'm assuming that if a goal doesn't get reached, and I'm just going on what I know of crowdfunding, that you can take your funds back. You can claim when the goal wasn't reached. But when the goal is reached, then the funds go to the people, to the creator, I think.
Yeah, but what
You know what I'm
about
saying?
like the consoles? Like there's consoles which checks, like if you look at the code, like the claims function checks if
Yeah.
the current
Okay.
funds is greater than or equal to data goal. But
Yeah.
then the console one is the one which checks if the the goal or the amount rather.
Yes.
Like I'm not sure if
Yeah,
they wanted to
go
see.
go to cancel one. Which one?
So
I think scroll up a little bit.
the creator can't cancel unless the funds are zero. But if there are funds, then the creator can't cancel.
Oh, okay. Well,
Jason, is that what you're yeah, yeah, I think you've got it. Um,
no,
let's
I
go back
want,
to that design. Yeah, that design
yeah,
doc is sort of helpful there because it's basically it's basically getting us to the context. Um,
This one?
yeah, creating nothing.
There must be datum that contains the campaign information. Okay. The creator of the campaign ID token requires the signature of the campaigner creator.
So that's all transaction one. That's how you put the first UTXO in the validator, I'm guessing. So now we have transaction two.
Which is so this is create campaign. Okay, this is cancel campaign. Inputs are transaction fee, okay, and UTXO with crowdfunding campaign information to be consumed, okay.
Yeah, what we just made.
Yeah, and the outputs are any remaining value back to campaign creator, okay. So they are locking value.
Oh,
If that's the case, they are locking value.
They're not tagging the outputs though, so it's
Yeah,
it could be
the
one of our
outputs is
holes.
any remaining value anywhere, right? It
yeah.
doesn't need to go back to the campaign creator as far as I've seen so far.
Tagging
But the
outputs. I'm
conditions,
not familiar with that phrase. What do you mean? You've
what
said it a couple of times now.
it's important.
Tagging outputs.
Yeah,
Well,
I use that specifically because I've seen Aiken people use that term. So I think it's important for us to use as well.
What does
Tagging
it
yeah.
mean?
outputs.
What does it mean tagging outputs?
It's validating or counting the outputs. Like you need to pay
Oh,
50 ADA to this
Mhm,
address. And
mhm.
so I do some function like value greater than or equal going to this address. Right. I'm checking all of the outputs for specific data that I need to work, like
okay.
the amount of ADA going somewhere. And so that whole kind of logic of validating the outputs is I've seen used as tagging outputs.
They just say
Mm,
tagging outputs. Okay.
okay,
Yeah, that makes
okay.
sense.
Makes sense.
That's good.
And the conditions for cancel campaign are, we already saw this. Datum funds must be 0. Datum campaign ID is the same thing. And redeemer creator is the guy who created the campaign.
Yeah.
Okay. And support a campaign. I am interested in this. So UTXO with crowdfunding campaign information. Okay. UTXO with support value plus transaction fee. Okay. So they are directly sending it to the
So
validator.
right.
Okay.
Right. Okay, so you support with your support value. I'm gonna support it for 50 ADA, and here's the 50 ADA plus my transaction fees. And
And
your
you're
spin.
spending that first one that was put in there, right?
Yeah.
Yeah. Okay. So those are our two inputs or our two UTXOs. So that makes sense.
So
And
tell me one thing. What happens when the second guy comes? The first guy spends that UTXO anyway, and does he put that UTXO back?
well, we don't know yet.
Oh,
We
we
haven't
don't
gotten
know.
that
Okay, the
far.
Ah,
UTXO with crowdfunding update campaign information. Okay, UTXO with support value. Oh, so he has to put that back in.
Yeah. Or the next person has to spend it. That's all we know so far.
UTXO with crowdfunding updated campaign
how
information.
how do
Uh-huh.
you?
It's
Okay,
probably
this
going to
is a
the same
mental.
address, but
Yeah. Here's a mental model sort of question. When you spin the UTXO, but you're gonna, in my mind, you spend it like you take it in. It's like a dollar, and you give a dollar, and then they're gonna give you change back a dollar, and it's like the same dollar. Or do you consume it? Like when I consume something, I eat it, and it's transformed, and I make a new thing. You know. So
Yeah,
my
yeah.
mental
So
model,
so
like,
yeah, it cannot be
yeah.
the same thing. Once a UTXO is consumed, it's not a UTXO anymore. It doesn't exist. A new one has to be created.
Right. So it's a new UT. The output is a new UTXO that may look exactly the same,
That no,
but
because you
it's
have to update the datum in that UTXO. Remember?
that's true. No, that's true. Okay. So it is transformed in some way. And does this get into like mutability, like coding, computer science? Is this back to our computer science thing?
I think it's all mutable. Like you can always change it, and you do it in
Okay.
that moment that you're talking about, where you kind of destroy or consume the current
Hmm.
UTXO. You eat it, and it disappears forever, and then a new one is created. You shit out a new UTXO.
Exactly. The other end. the other end of it. I'm sorry that was.
And so that when you shit it out, you can create whatever you want. Like it doesn't have to have the NFTs that the old UTXO has. It doesn't have to have the old datum. It doesn't need anything else besides like the conservation of values, right? Like it needs to be 100%.
Right. And that's what
And
the validators check. You know, it's just
the
like, hey,
validators check that. Yeah. So
are
if
you
you
eating
want
the
the
right
datum
stuff?
to, yeah,
Yeah.
exactly.
And are you shitting out the right stuff? And I don't know
Yeah.
if I want to use that as as the
You talked about
analogy.
eating it.
I know I
What else
did.
happens
I
after you
know
eat it?
they say consume. Oh dear, oh dear. It's the German, it's my Germanic. I think they have a lot of things about the like shitting and butt stuff and yeah, anyway. But it's like but we are inputting and outputting. Let's just keep it like that.
Yeah,
Yeah, I
I
think
mean
of
that's how we get canceled on YouTube.
Yeah, don't get canceled. We're not canceled. We're happy with happy people.
you can censor me, Harsha.
Ah,
So the
it's
second
fun.
condition is this: UTXO with support value and corresponding datum for support UTXO. So they're using a different word called support UTXO, which holds the value and apparently it has some datum, and I'm not sure what datum goes on to the support UTXO, by the way.
Yeah. Okay.
Dude, okay.
mm, and what are the
Conditions.
conditions? Redeemer includes the supporter and amount. Okay. So, but that is just the crowdfunding UTXO. Oh no, this is the redeemer. Sorry, yeah. Includes the supporter and amount. So basically, I'm guessing we check which UTXO we are spending based on the supporter and the amount that supporter has put in the support UTXO. Okay. Support
Hey,
value must be provided as input. Okay. As input value among the non-script input UTXOs. What does this mean? Support value must be provided as input value among the non-script input UTXOs. So I am assuming non-script input UTXOs are input UTXOs that are not in the validator.
okay.
Support value. Well,
Yeah.
I'm still not
Yeah,
clear
yeah,
about
yeah.
this sentence. Does anyone have
So
idea as to what this is trying to say?
I can yeah, that basically there's enough funds in the wallet, the non-script input UTXOs, like that are in the non-script means wallet. So there's a script
Oh, okay, got it,
like
got it, got it. That so
yeah,
this is for supporting, right? So the guy who is
yeah,
supporting it has to send in an input with enough value that he wants to support the campaign for,
right.
as input.
Eh,
And this input like gets spent and becomes like the UTXO that exists that ends up in the validator.
Yeah, yeah, yeah.
Make sense? And the last
Yeah.
condition is datum.current funds must be equal to its input value. Datum.current funds must be equal to its input value plus the defined support value.
So they're tagging inputs,
They are. Yeah, here,
but
but
not
we
not
just
outputs. That's the input value matching the current funds. So does it say that though? I think it doesn't. Support campaign is only checking datum.campaign ID equals campaign ID and must be signed by. Yeah.
Yeah,
So when that says that, I mean, that whole line is just not part of our validator.
not yet.
Maybe it's
Yeah,
part of the supportive one, but it's not here.
yeah.
In which line? And this is which? Go scroll up. Which transaction is this? This is the
TX3.
no
Support
TX3,
campaign.
Yeah, it's 3, the support campaign.
and that's line 89-ish. Support campaign. Okay.
Yeah. Be signed. Yeah, I mean, this one doesn't explain it. Maybe does it do anything here? No, it's just the function. So
I think
Where's
it's
the
taking
supportive validator? There must be another validator as part of this, or no? It's literally just this.
no, it's literally just this.
Yeah,
Okay, so I mean, those docs,
89.
the
Yeah.
docs don't equal the code.
Yeah, they're
I
missing
think the,
some stuff in the
the
code.
expectation is that we read the docs and we update the code to match the docs.
Yeah, I think you're right.
Okay, so this is like a little homework assignment.
This was part of a course. I don't know. I couldn't find where they're offering this course anymore. But yeah, this is part of their MIT licensed open source coursework. So
Okay,
yeah,
so I mean, now it's less of a nuisance and more of a challenge to me.
yeah,
Um,
yeah.
so is that what we're doing? Because I would say we need to tag that input. We need to do that line. Datum.current funds must be equal to the input value plus the defined support value.
Yeah.
I would say we should add that because
So
I see the other ones.
what is the defined support value? Is it just the value that the backer wants to give?
No,
Yeah.
what the CF, the crowdfunded amount is, like what the owner wants to collect, right?
No, this is no owner.
No,
No, this
you're
is
right.
support a campaign.
No.
Remember, this has nothing to do with
Yeah,
the
yeah.
owner.
I think
Yeah,
the
you're right.
support
You're right.
I think the support value is the value from the Docker, and then the input value is the value that was already in the datum. So
Oh,
Yeah.
oh,
Okay. Makes sense. Makes sense.
yep. That's it. That's it.
Okay, so datum
So
must.
the input must be equal to the input value plus the value that's already there. Is that right?
Yes. So they're basically saying the datum dot current funds must be updated to this value, which is the
Yeah.
input value that is the previous datum dot current funds, and we are adding whatever support value the backer is wanting to give to this campaign.
So it accumulates, meaning every
Yeah.
time somebody supports, the datum.current funds will be added onto that value. So then the next person gets it and they would add on to it. But
Yes.
okay, so I two people could do the same thing.
How do you mean two people could, as in?
Ooh.
Well, I mean, this is a similar pattern to not cache,
Mhm.
and I use the state threaded token, the unique NFT that counts up one, and then always shares that UTXO with the NFT. And so the point is, to accomplish the same thing of like some value that I can accumulate through transactions, but from my understanding, you need that state threaded token to ensure its authenticity, to make sure that it always gets updated accurately. Because, but I guess I'm trying to
Yeah.
learn and trying to figure this out. The
Y-
problem would be if multiple people tried to change current funds at like kind of the same time, but I feel like
Ooh.
one of them would just fail. It would try to spend a UTXO that's not there,
Exactly. Yeah.
and then the one that did would work. So why do I need the state threaded token to begin with?
And the state threaded token is sort of a general pattern for this accumulating
Yeah.
value and a UTXO. Okay. Okay.
Well, yeah, but I could be a little wrong there, because what I know for sure is it's the pattern to get a real NFT, right? The problem with an NFT versus a fungible token is like they're all fungible tokens, and it's like
Right.
you have to do some additional logic to get a unique NFT.
Mhm.
And the way that you accomplish that is with the state threaded token. It's like that's how
Okay.
you can get a unique NFT and like guarantee the uniqueness. So that's what I used, and then I started accumulating the count or whatever. In this example, the accumulation of the current funds. And so I'm just trying to think like maybe you can do the accumulation without the state threaded token, but you wouldn't have got the unique NFT names.
Yeah.
But you could have still, like in this example, you could still track the current funds.
Yes. You can track the current funds. Yeah.
You
So
can track the current funds.
whatever
Okay,
action
let's
you
see.
do, the first thing you do is you spend the campaign UTXO. That is the whole validator, I
Yeah,
think.
yeah, and that's how you get the pub datum, and that has the guarantee of the blockchain, meaning only one. It can only happen once. Like only one person can spend it.
Yeah, correct.
So
And
yeah, I mean, to me, the current funds would accumulate accurately, as long as yeah. If you did that line, if you actually tagged the input values and checked with that current funds, to me that seems like it would work, which is
yeah,
cool. I feel like I've learned something. I have extracted or I've compartmentalized some logic that used to be in one compartment.
okay. Fair enough. So what do you guys want to do? Should we just like start looking at each of these and start updating the validator to batch all of these? Say for example, cancel campaign, like just check if it is taking care of all of this and update the validator? Or do you
Yeah.
want to go through the whole thing and then
Well, let's go. We just have one. We have two more to go. So transaction 4 and transaction 5. Let's do that, and then we might be at a time because this could be like a homework for next time, and or like if we wanted to stay on this one for another week, and
We
maybe
could continue on through and just do this. I mean,
okay. All
I
right.
don't
All
care.
right.
I think Harsh is Don, so I think he's got to make the decision, right?
Yeah,
no?
you
So
got to make
as
the
a Don,
decision,
I'm
Mr.
giving the
Don.
capos. I'm nice like that.
No. It goes the other way though. It goes the other way because
Go
we like
bad.
we need the authority,
Yeah.
just
Yeah.
make the
Otherwise,
decision.
hey, I
Okay,
just started
fine.
watching
I'll
The
make a
Departed.
decision. Let's get this done then this week because
Let's
next
do it.
week
All right.
Lewis needs to like do it. So let's get this done
Okay.
this week. Okay.
Let's go.
Okay. So now that we are here anyway, let's quickly go through the other two as well and try to
Yeah,
make
let's do it.
changes. What it's 9:46 already, so we have about 45 minutes. Okay.
Yeah, we can do it.
So claims when goal is reached. So the inputs would be UTXO with crowdfunding campaign information, which is just the campaign UTXO. All UTXOs with campaign datum ID and backer support value. So I'm guessing the support UTXOs also have datum, which has the campaign datum ID and the amount that they want to support. And just like transaction fees. Is that making sense? So for the for support transaction, which is like the backer transaction, they consume the campaign UTXO. They create a new campaign UTXO with updated values, and they send another UTXO with the amount that they want to fund, along with two things. Along with the datum, which has two fields. One is the campaign ID, and two is the amount of ADA that they want to support with.
Sorry, TX4 claims this is the backer who is now withdrawing all of the raised.
No, this is the campaign creator who's withdrawing.
Yeah, that's what I'm saying. That's what I meant. It's the campaign creator who is withdrawing all of the individual backers' money.
Correct.
And so the UTXO with crowdfunding camp, that's like the shared UTXO that they all have spent. And then all UTXOs with campaign datum.id and backer support value. So that's saying all of the ones that have, all the backers have come before, they've put a campaign ID on the datum. And so we're able to,
and backer support value on the datum.
yeah, and so we're able to search those UTXOs and include them.
Correct.
And then the third line, UTXO with TX fees, I feel like that is just, that's the boilerplate. Like you always,
that's just the transaction fees necessary to get all of this done.
and every input that's going to be there.
Yeah. Okay. And then all value goes to the crowdfunding creator.
Yeah.
Right. So that's, you would tag that.
Yes.
And conditions for
learners.
Yeah, this is they're actually speaking to us for learners.
Yeah. They're like, oh, you got this far? Okay, you got to do. So basically that
okay, so that's how you win, or that's if the goal.
That's how you withdraw. Yeah. If your
this
goal is
so
reached.
similar to not. I mean, the pattern is so similar to not, which is cool because this is just awesome. It's like a fundamental pattern. So claims 5 is, this is when you haven't reached the goal, and
so UTXO with crowd, okay.
That's the standard, and then you're gonna try to spend all of them.
All UTXOs with campaign datum and backer support value. Okay.
So it's the same inputs. It's the same inputs.
Yeah, it's the same inputs, but one thing I think is checked. Each supporter value goes back to each supporter. Okay.
Right.
Okay. I get it. I get it now. So basically, in the original CF datum, they have a goal, right? That goal is always a constant. So if the goal is reached, then the guy can claim all of them. Otherwise, they go back to the backers.
So how do we write that in code? If the goal is reached, that's it. Like what?
So it's actually pretty simple. You know why?
Yeah.
Because you just compare amount section to the goal section in the CF datum, and then that's how you know.
Yeah.
Well, I think the transaction 5 needs to tag all of the outputs.
It doesn't. Tag as in it basically has to have all of the UTXOs so that they can be sent back to the original backers.
But each one has a unique backer, so like you need to have all of them, and then understand where it's supposed to go, and then
where it's
tag
supposed to
it
go
and validate that it's actually going to that place. So
correct. Yes.
And that would be, I mean, there has to be a limit on that.
Yes. Otherwise, the transaction.
This is where I look to Lewis. This is where I look to Lewis. Lewis is really good at this stuff. Lewis, how are you doing, buddy?
I'm good. Sorry, I was in the washroom.
Oh, no worries.
Yeah, he's backing himself. Yeah.
I'm good at what?
Nothing. I'm kidding.
No, I was just teasing because this is the because that in my mind that is like the crux move. Like that's the kind of the trick hard part of how do you when you
time. Sorry.
I was buying time a little bit because I think that when the goal is not reached, and I think Unspent just explained it. He's like, look, all of the funds have to go back to the individual backers who back them. So it can't be like how do you redistribute it once it's all gone in? So I think that's going to be the hard part, to be honest.
Yeah, and also like one other thing is like, what if there are a lot of UTXOs, right?
Yeah.
So this is where I'm telling you, this is not like this whole fucking thing is not, because what I did was I gave them an NFT and then I locked that value somewhere, and I allow them to trade in their NFT for the locked value.
I got
So
it. Yep.
under the situation where goal is not reached, how do you actually get the value back to all of the individual backers? Well, if there's 10, then you could just make one transaction and send it to all of them. But if there's 10,000,
Yeah.
then you have a
Doesn't
problem.
scale.
And like you have to these like crazy transactions where like you have to validate all of this information where like here's the output and then here's where it's going, and you need to do that for all 10,000. So the way I did it was kind of extract the logic away and like let them deal with that themselves.
Yeah, and just practically speaking, if I am the campaign creator and I haven't reached the goal, so I won't be getting any money, why the fuck would I spend more money to like send everyone back their value? I would just be like, yeah, whatever happens, happens.
Yeah, right. You have to
Ooh.
out of the goodness of your heart, but I think the point you're saying is like yeah, or like
Oh.
the creator can't be like anybody should be able to launch that transaction.
Correct.
And pay for the fees so
Or at the least, like the backer should be able to get their own UTXO.
yeah, which
Well,
isn't that cancel?
No, so if you go
You're
to
right,
cancel,
you're right. I know, I remember.
it's still where is cancel? Support. Yeah, cancel campaign must be signed by the creator. It's still the creator's
it's the
thing that is
creator.
being checked.
Yeah, but I think there's a missing redeemer action for claiming funds. Okay,
Claim
okay, so
funds is
yeah, go up to the
okay,
redeemers. Yeah.
two.
Oh, okay. So in two, wait. So yeah, what I'm saying is there's one for
Yeah.
where you cancel the campaign if the goal hasn't been reached, and there's
Correct.
one.
Yeah. So we need a.
where
Yeah.
So should we add
Keep
that
going,
to?
Jason.
Actually, so claim when goal is reached, claim when goal is not reached. So claim when goal is not reached is just canceling the campaign. No, or am I getting that wrong?
No,
No,
yeah,
it's sending the
I think what
UTXOs
Jason is.
back.
Oh, you're right. So yeah, we need to add one more then. Yeah, you're right.
One more
You're right.
redeemer. Jason, that's what you're saying, right? I think
Oh,
we need
yeah.
another yeah.
Oh, we either add one more redeemer or we include this logic in the claims redeemer. So
Yeah, we just add one more action here, right? Say, for example, I can
Or
put
yeah,
put
either or, and that's true. Jason, I think is right. I kind of like it with its own redeemer type.
why?
But it could be claims fund.
It's
You
more
know,
like
and then
refund, or maybe
yeah,
refund isn't the
refund.
right language, but it's
Oh,
not
yeah, yeah,
claimed
yeah.
funds anymore because
No,
you're
Refund when goal
sending.
is not reached. Yeah.
refund. Yes. Yeah. Then it's a whole nother verb, a whole nother
Yeah.
redeemer. Jason, what do you think? Does that
yeah,
satisfy?
I think that's better than having it in the claims funds thing.
So
Yeah,
let's
cool.
write that really quick because I want to talk about the logic of tagging all the outputs.
Yeah.
Love it.
Right. Just
Because
write the third one.
yeah,
It's like this guy, refund.
yeah.
And then we'll have to create a refund. Yeah, but let's just quickly write that function. Must be signed. So
Also, what's it with the transaction fees? Are those like transaction fees to help with the refund or?
transaction fees is in general, like whatever action we are doing, you still need transaction fees, right? For the blockchain to work.
Yeah, but every action, like in the design doc, like to do anything, you always have to add some
Transaction
Yeah.
UTXO
fees.
transaction fees.
Yes.
Yeah.
Yes.
I think it's more off-chain like
How do you mean?
considerations.
Yeah. In general, like the off-chain part takes care of it, but yeah, you need that extra transaction fees.
So, and this may thinking of transaction fees, and this is something that Harshit brought up about like, okay, canceling. If you're gonna put it on the the owner or the originator, the creator, to pay the transaction fees to send the money back, that's kind of a logical, like human nature sort of thing. So just as a feature request, it could be that we add, I don't know if this is, I guess this could be off chain, but we can validate it by saying, is there like, contingency fees
So you know
are
what I
collected?
think? Not a contingency fees, but a simpler way to do this would be, instead of the campaign creator to withdraw, if the goal is not reached,
Oh,
any of the backers can remove their backing at any point in time.
that's
But now
it.
you need a concept of time.
No, I didn't say time like Newman did. I'm saying
I'm
Oh
if
saying that
you
shit!
we
Did
do.
I say time?
eh,
No,
When
I'm
did I
saying
say
we
time?
do. I'm saying we do. If we do what Harsha just said, which I agree with it,
no,
but
no.
I'm saying if we
Uh-huh.
do that now, we need to introduce a concept of time, because we will have broken the campaign. Like if I look at the campaign and there's the goal is 1 million and we're at 800,000, I'm like, okay, cool, I'll put in a little because we're almost there. But then like the other backers just withdraw their funds, and like
Yep.
I feel like they can't do that until the auction is
There's a time.
over.
Correct.
Yeah,
So
and
yeah,
therefore
Yeah.
if
then
you
you need
introduce
time.
like time in the datum, then yeah, that's right. That makes sense. That makes sense. If you introduce time, then we are preventing the backers from removing their backing before the time ends, right?
Okay. Um, is there another way to prevent the backers from removing? Does it have to be time? That's what I'm saying. Like, could there be like the creator just has a Boolean, like it's no, the campaign is still going. And then he could effectively lock it because he has the switch to
I
make it
think that's
available.
what this doc is describing now. Is kind of like the creator would have this function where they can refund all of the value for all the backers if they decide that it's over. But
Yeah.
it's just it fails because of that, and like they don't have to do it, and it costs them extra money. It's just like a bad design choice. I think the user wants to have the power. Like it should be way more focused on the backer to like be able to put their money into something that they trust, and then be able to withdraw it if it doesn't happen how they want it to. So
And
to
it's
me,
not up to the
I would want anybody to be able to sign this refund transaction. And it would be cool, like maybe we did it in a way where it's like anybody could sign it, and it had to include 20 or something. So I don't know, like instead of the creator having to do it, what if you had anybody do it, but like it also ran transactions for the no, I don't know.
So for me, this again brings up, even if you put time and all of that, and the backers can withdraw their UTXO whenever the time ends. Say for example, if it's 10,000 UTXOs, the validator will still have to like go through 10,000 UTXOs to find. I mean, that's the worst case. It'll have to go through 10,000 UTXOs to find the UTXO that the backer has to spend, So it's still like a pretty compute heavy situation.
Well, the off chain does that work, and then the off chain sends the right inputs in.
Yeah, I think another way you could. I think another way you could do it is you have like every time someone box like supports the campaign, you put a transaction to refund them, but you don't run that transaction. And then if
So you're speaking about off chain, is it, Jason?
Yeah, off chain. You can do it off chain. I don't know if you can do it on chain, but in off chain, you just create a transaction that basically returns that money, refunds that money. And then when you reach the when the deadline reaches or something, and then you haven't reached a goal, then you run those transactions that you created earlier.
So that means we would need like a database that stores all these transactions, right?
Yeah, something like that. Like if you can't do it on chain, like
Yeah. Interesting. Yeah, that's one.
because
Interesting. What do you?
We got to do it all on chain though.
Okay.
I think. I
I
mean,
like
I
that. I
think.
like that idea. It's sort of the just in a principle, it
Yeah.
just says, hey, like we know, yeah, I don't know, it just seems evolved and it's just like, oh yeah, I get because it's sort of like I don't know what the analogy would be, but yeah, it's like getting things ready beforehand, and then it said that your exit, the exit, the fees, the transaction, everything's there and set.
Yeah, makes sense.
And would that address that sort of computational thing of searching the long UTXO, like the address with just a crap ton of UTXOs on it? I mean, what is like a big UTXO list? Like, what are some of these like DEX wallets and scripts? Like, what do they have?
So
Thousands
it
and
is like a
thousands of.
two-way thing, Newman. See, remember. So if we
Yeah,
do the off-chain thing, then
yeah.
we are using the database, you are using memory. If it's an on-chain thing, you're using computation. So it's like a one way or the other. And by the way, Ahmad, you raised your hand, so please feel free to come off mic and speak. You don't have to like raise your
Yeah,
hand.
yeah.
Yeah. So I was actually thinking, you gave an instance where, for example,
Mm-hmm.
1,000 is being asked by the person who created the campaign, and
Mm-hmm.
then maybe 800 at the end of the day has been realized. So I was thinking if there will be a possibility of implementing a milestones where funds are distributed in milestones, so as not to actually return the whole thing back. It defeats the purpose of actually creating the campaign in the first place. So I was thinking,
Yeah.
is it actually possible?
How does that how do milestones work?
Yeah, yeah. Tell us more.
So like I was thinking,
Mm-hmm.
maybe this fund actually okay. You're asking for 1,000. Maybe when the campaign or has been funded up to like 500, these funds can be released in bits, something like that.
I
Oh,
see.
so
You
you're
know,
saying
at least
like,
at the end of
okay.
yeah.
I think I get what you're saying. So if the campaign reaches 500, you can actually take the back, not the blacker, the campaign creator can take 500, right? Is that what you're saying?
Yeah.
I mean,
Yeah, that's what I'm saying.
I mean, it is possible, but how is that different from just saying the campaign the campaign goal is 500, right?
Right. It'd be like you could conceivably just create little smaller campaigns, but he's thinking of like a compostable, like different, like there's a little this campaign and then that campaign. Yeah,
Yeah, so it's just like campaign
Mm.
with like different little steps. So
steps. Yeah.
the campaign the guy who created the
Yeah.
campaign can keep getting money in smaller.
Oh, this sort of
Yeah.
makes me think of unspent. It sort of makes me think of not because it's like if it makes to this, then certain backers can do this. There's some logic in there that kind of makes me think of the not logic. Um,
I like what I want to do is boil down the fundamental problems and goals that this contract or a contract would try to solve, and like just
yeah,
really try to understand what those are, and then try to solve it from the ground up instead of taking this. I mean, well, I don't know. Maybe this is a good start. But
well, we've got those learner activities like to do the
Okay, so
conditions
how
on
about this?
transaction four and
Let's
five.
pick one
Yeah.
thing and get that done. So pick one of these guys and let's like implement it. Anyone has any ideas? Jason, do you have any preferences?
Yeah. Like for sake of learning stuff, I'll pick TX5.
TX5,
Seems the most interesting.
goal not reached, right?
Yeah.
Okay, let's do that.
Yeah. Definitely.
Okay, so which is refund when, so number 3. So first we need to add 3. And I just put like a refund, which is a function. So let's start writing that function. I started writing
Beautiful.
that function somewhere. Okay, there it is. So this is the function. Okay, so it is the AI is already giving me some things. So first thing you'll need is the datum,
Yeah.
campaign ID, signatories. Would that be enough? I'm going to accept this for now, but we can change it up.
Yep.
What do you think the inputs for this function need to be when the goal is
So
not reached?
so go back to our design document, because in the datum we're going to need.
So it says UTXO with crowdfunding campaign. That is definitely needed. So that means we have the datum here. Where is this?
Yeah, that's
So
CF
that
datum.
we just need the datum here. The campaign ID comes. So the campaign ID is coming from the redeemer, and the
Oh,
signatory is just like the guy who's signing it. So how do you
well,
want to
let's just.
implement this, by the way? Since Jason suggested this, Jason, is there like a preferred implementation that you have in mind for the validator?
Yeah. So I think one thing I would change. Okay. Like I'm not sure how much data this will take in the on-chain part. Like one thing I'll change in the data is I will include like a pub key hash list of all the backers, just to be able to know who backed it. Like
Okay,
But we
so
can.
so
This
in
instead of
is
that
like
checking
case,
through
this
UTXOs.
becomes like a
we have such small limits though. So like anytime you're talking about a list like that, you have to be talking about the clever ways to deal with bigger lists, because it's like 50, right? If we have under 50, then cool, we can store everything in the datum on one UTXO. But
yes.
the bigger list, it's like it just doesn't work. You literally can't do it. You have to do other ways of handling large data sets. So like either linked lists where we use pointers and we create different UTXOs that point to other UTXOs, or we use I don't know. There's right, or you can use the NFT method. But this is what I want to talk about as well. It's like, because fundamentally we're trying to return the value to the people, right? So that value was put in with the UTXO. We will have that as the input. Won't we already have the address that came from if we're looking at that input?
Yeah. I think.
Yeah, it will have the address. Yes.
So
Okay.
could we just take all inputs and then make sure that they go to their previous address, and like all that information is already included in the input? So we're not even having a big list in the datum.
Originally the idea, so this backer part in the CF datum, I think is only the last backer that backed the campaign. That's what I understand, because the rest of the UTXOs, the backer UTXOs, will have the campaign and the verification key hash of the backer, as far as I know, right?
So, but we're trying to refund all the value when the goal is not reached.
Correct. So I'm
So,
saying each of the backer UTXOs will have in the datum will have a campaign ID and their verification key hash
okay, so then we can use that verification key hash
to check
to
if it is
generate
being signed by the same guy.
No. I guess it depends what we're talking about. I'm imagining a bulk transaction.
Oh, so okay, so one clarity. So are we assuming that the campaign creator is sending back the funds, or are we assuming the backers are claiming their funds?
I think with this contract design, like if you go to TX1, I think we're assuming that the campaign creator is sending back the funds.
Okay. Okay. So let's stick to that then. Yeah. Let's
you have
assume
to
that
include the TX fees for when the goal is not reached, right? So
yeah.
like if you go to TX1, like there's a field there, like
If TX1
enough
has
ADA to
create a
cover.
not this one,
Uh-huh.
right? You are speaking about
Yes.
this
No,
one,
no,
right?
just
Cancel campaign, support campaign.
just the design doc. The design doc.
Design doc. Okay. Yeah.
So enough ADA to cover, create TX fees, and claims goal not reached TX fees.
So this is what I don't understand. How will we know how much fees is
Exactly.
required for goal not reached when creating
Yeah.
the?
So we can't know.
Yeah.
So it's by design. Okay.
And
So is there a way to find out which UTXOs are in the particular script address that we're currently doing?
Yes, that would be an off-chain thing, but
do it on chain.
the campaign guy, the guy who created the campaign, will have to input all the UTXOs from the validator address to do this transaction to claim goal not reached.
I think you could just add extra UTXO to cover the fees. I don't know what.
Yeah, I mean, I think, yeah. So when doing this transaction, I feel like, yeah, the campaign creator has to add this extra fees or just add
To me,
fees.
the part that is new or novel here is how do we refund all of the value? We have a huge list of unknown number of lists, and we're trying to refund the value under this event. And
Correct.
so we're going under the assumption that this is the creator who needs to craft a new transaction that says the goal was not met, I'm refunding the value.
Correct.
Okay, whether that's good or bad, like that's what we're doing right now. So how do they do that? They're gonna off chain, they're gonna look at all of the backing UTXOs that they have, and all of those will have come from an address.
Correct.
Okay,
Yeah.
so we have, like, we literally could query all those UTXOs and then run a function and like get all of the addresses. Meaning we don't have to store it in Datum. We don't have to do a linked list. We already have it, I think.
Yeah.
So what I think is the Aiken validator for this specific transaction needs to take all of the inputs and then make sure that that there is a corresponding output to whatever that calculated address is. So like if Harsha and Newman put in, if they were backers and they both sent a UTXO into the thing, and then I am refunding it, I'm going to take those two UTXOs and I'm going to
I agree.
pass them through a spending validator that needs to check the address that it came from and that it goes back to that original address. Meaning all I have to do is, I said it.
So I'm just putting a UTXO, which is an output reference, because that's where you get the address from. You check Datum campaign ID is campaign ID. You check Datum current funds is less than Datum goal. And UTXO reference, not UTXO reference. And let me accept this. UTXO dot reference. I think this UTXO dot output dot address is equal to.
Is it that though? Maybe it needs to be the address that it came from, not the address that it got sent to.
No. You need both.
Okay.
You are making sure that the address it came from is the same address as the address it's going to.
No.
How come?
At this point, that UTXO has been put in. it's so hard. I'm using the analogy that you were the backer and I'm the creator. You sent in your transaction to where
You said
to
you
the
are the creator, right?
yes.
Uh-huh.
Yeah.
And so you created the UTXO and you put it somewhere, right? You put it in this contract. So
Yeah.
the output reference now is the contract address. It's not your original address,
Oh,
right?
you're right. Fuck. Yeah, you're right. You're right. Yeah.
Okay, so we
Right.
need to know the original address that it came from.
Oh, so in that case, we'll have to say that the datum for the backer has to have the address. Then we can check, right?
Yeah, I think we can assume that we can get the address from off-chain and then pass it as a parameter in the refund redeemer.
But what would we check in the redeemer though? Like, if say we are getting the address from off-chain, what are we checking exactly in the redeemer? So my assumption was we would be
checking the-
checking if it is going to the right address or not.
Yeah, and can't you get that from a transaction thing, like in the like if you pass in a transaction, like the transaction contains the list of inputs and the list of outputs, and then
Correct.
in the list of outputs you can check whether this particular output reference is going to a particular address in the list of outputs.
Can we get the data from the inputs though directly, or do we need to look at it off chain and then pass it in with a redeemer?
Yeah, so if we are looking for the addresses in the off chain, I'm just saying because we can't pass any information.
Yeah, you pass it with a redeemer. You can pass in whatever you want.
So the yeah, I mean, I guess we can pass it with a redeemer, like, but that would still add like a lot of. So that means the redeemer basically would have to have all the addresses of all the guys who have backed this fund this campaign, right? In the redeemer.
Yeah, and now we're hitting our problem of the big list.
Yeah.
I don't think so. I think we can have one. We can have one UTXO in the refund redeemer, but then in the off-chain we have a huge transaction with multiple redeemer with multiple like UTXOs for the like. Okay, so here's what I'm describing. In the on-chain, we just check for one output reference, but then in the on-chain we check for one output reference, but then in the off-chain we create a transaction that is multiple output references.
Correct.
Oh, but then it's like, you might as well just be using Stripe, right? Well, I mean, that was a real question. I didn't mean to like, I really, wouldn't that be right? Like we're removing all of the security of the blockchain by relying on the on-chain, or sorry, on the off-chain logic to handle the refunds correctly.
No,
right?
No, I think the refunds, like in the off-chain, we're just creating a huge transaction, right?
Correct, with all the UTXO backer UTXO as inputs, right?
No. Like it's a list of multiple transactions, and in each transaction we're using the refund redeemer.
And for each of the transaction, the refund redeemer is different, right? Each refund redeemer points to one address at a time, correct?
Yeah, exactly. Like one output
so
reference at a time.
Yeah. So it's not a batched transaction. It's one transaction per output. And so if there was 1,000 backers, the refund would take 1,000 transactions to send it all back.
Correct. Yeah.
Yeah, but it can't be it can't be a batch transaction. You just have a batch transaction with multiple redeemers. I don't know if that's possible, but that's something you could
do. What am I missing? I don't understand.
So think of it like this, unspent. So here in this evaluates, this is a spend, right? This evaluates one UTXO at it. Oh, wait a minute, but that one UTXO is this. Wait a minute. How does that work?
It gets run on every UTXO in the transaction.
It
Every UTXO at the spending validator that you want to spend,
You're right.
you
You're
have to
right.
run this logic.
That's
So if you batch that with 1,000, then you have to do that 1,000 times in one transaction. Or if you ran 1,000 different transactions, then you just do this 1,000 different times.
correct. So this UTXO reference keeps changing, right? For each of them in the spend, this parameter keeps changing. So it'll have
Yes,
1,000 different output references, different ones.
correct. Yeah.
Okay.
Yeah,
Yeah, I
that
mean,
is,
we
that's
can do
totally
that.
right.
So, but I am saying instead of like the whole off-chain thing, say we have one more pub type, right? Pub type backer datum, and this datum would say have just uh, campaign ID and backer address. So now we can just check if the output's address is the same as the backer address on the UTXO, no? Then we will probably eliminate the off-chain, will we? Yeah, I mean, we'll still need a little bit of off-chain, but does
You're
this make
saying
sense?
the individual UTXO that
Uh,
the backer puts in
uh-huh.
includes their address to send it back to.
Yeah.
Okay, so our shared datum is the one above this, right? It's the CF datum.
Yes.
That's shared. And this new, right, that one is shared and
Yeah.
gets spent every time and updated collectively. But what you're saying is the backed datum would be on the individual UTXO.
Correct.
Okay, so then when you're spending that UTXO, you have its datum that you can just check is the right. Then you have
So
the inputs with the datum, and you have the outputs, and you could tag it all and check.
correct. That's what I'm saying. But I am saying when in this case, in this scenario for the refund, we are not spending the campaign UTXO, by the way. The campaign UTXO becomes a reference UTXO where you're just reading the value.
Yeah, I don't know if it's designed that way yet, but it certainly should be.
Yeah. I mean, not right now. It is only for the refund, is what I'm saying. For the rest of them, it should be spent and recreated. But
Yeah.
for the
But we can
refund, it
use
should just be like a, because we are
sure.
spending the refund UTXO, by the way, right? Because a spending validator always takes the UTXO that is being spent
Mm-hmm.
in the parameters.
Mm-hmm.
And in this case, we are spending the backer UTXO. Is everyone confused completely at this point?
Wait a minute. Backer
Okay.
UTXO. That
So
back.
what Harsha, I believe, is suggesting is like we have this global state or whatever, the shared UTXO, the shared datum
Campaign
that
UTXO,
updates and
yeah.
stuff. That's
Yeah.
kind of like a global state.
Yeah.
And then he's talking about adding a local state on each individual UTXO,
Correct.
such that when we spend that UTXO, we have its address that it needs to go to. So
Correct.
Yep.
we can check those on an individual level.
Correct.
Without adding this huge list that we need to like keep track of. We're able to do it individually by just adding datum to them. I think it's I think that's good. I think that's smart.
Yeah, I agree.
I could follow that.
So the Baka datum is added every time you support, right?
Yes, in each,
Yeah.
yeah.
So we would want to tag that input and require that, I think, right?
Yeah.
Meaning you can't support unless you have the proper refund datum or whatever, right?
Back to datum.
Yeah.
Yeah, I mean, I should change it to backer datum. Back datum seems, yeah.
Backer datum.
Yeah, or
And
refund datum.
help
Refund.
me understand how that would the backer datum, like, are they different? Because as I understand it, the datum is just one object. Would it be more than
No.
one object?
Datum exists in a UTXO, remember.
Yeah.
Okay. So the campaign UTXO is one UTXO with this datum. Okay.
Yeah.
A backer is sending a different UTXO to the wallet,
Ah,
to the validator address
okay.
each time they're backing. And I am
Yep, that's
saying
true.
in each of their UTXOs, you should
Okay.
have this information so we know where to send it back.
Yep, that's perfect. Yep. That's exactly right. Okay. So it's not like there's two different datum types on a single UTXO. It's
No.
just yeah, okay. Yeah, that's what I was
Yeah, there's
curious.
two UTXOs.
Yeah.
Yeah.
And that yeah. So do you want to yeah, I think that's a good sort of logically we figured out how to manage this closing, refunding, that new redeemer type, that new action.
And the backer address, tell me one thing, the backer address is it like a verification key hash or should it be like a string?
Uh,
I don't even know
It's an
if Datum
address.
accepts strings. I don't know if Datum does it accept strings?
It's an address. It is a type address.
Oh, it is.
type
Oh,
of address.
okay. So okay. So it is of the type address. Cool. Okay. So if we have that in our logic, what we would write, where is this? In our, so this would be the UTXO. Yeah. So we'll have that. So in our logic, we would have UTXO dot output dot datum, right?
Yeah, this is, it's not the CF datum.
It's not the CF datum. Yeah, you're right. Oh, this would be backer datum.
No, I guess that's not what I mean.
Uh-huh.
The transaction will have both UTXOs.
Correct.
And we're spending both of them, but we now have two different datums that we're concerned with.
No, I'm saying we don't need to spend both of them. We just need to. So
then it's a different validator. Right? Or no?
Why would so this validator has all the UTXOs, right? Whether it be the campaign UTXO or the backer UTXO, right?
Okay.
And this validator, the spend is checking for one UTXO at a time. Which UTXO are you spending?
Yes, but the transaction has all of them. So it's doing two things.
Correct.
Okay.
So in that case, the spend cannot have, it just needs to have datum here or data. And we will check the type of.
Yes, nice. That's exactly it.
Okay.
Yeah.
Uh-huh.
And for 3, here inside this, we'll write some logic to check if the datum is of the type CF datum or we'll just check if the type is backer datum here. Correct?
Yeah.
In this. I'll-
Okay.
So here we will have to write that expect statement.
Yeah.
Expect some data. And also here, I think we have to say, one more question here, which is like a high level question. When you are checking for the datum, you are supposed to say inline, right? Like what if this is just a datum hash?
Well, I
Hmm.
have not ever really understood that. I just have followed the rule of adding it. So
No. So all I'm
um,
saying is, instead of some datum, shouldn't we write inline datum?
yeah, I don't, whatever the pattern is, I'm agreeing with you.
No, I don't know the
Yeah,
pattern.
and I
I'm
do
just
get that.
assuming this is
I have no idea either. I have no idea either. Yeah.
I'll find
I've
it.
never
Hold on.
seen inline datum. That might be good to check the docs. Hey, it wouldn't be datum dons if we didn't look at them docs.
That's true. We haven't seen the docs yet today.
Yeah, that's true. So I'm just going to go to datum.
There it is. There it is.
So
My
I
favorite
saw that
it
purple.
says
beautiful
these, right? Datum
purple
hash and
inline.
inline.
Beautiful purple.
Okay. Completely inlined in the out. A datum referenced by its hash digest.
Correct. So
So,
we don't want this. We want this. So we have to make sure it is inline datum. So
but
everything we
what
are
do we
doing,
normally? What is it? But what is it by default? Because normally we
there's
just say
nothing called
datum.
default, right? It is what
Well,
we ran.
no. But when you just put export, well, like in there it says expect some datum equals datum. So,
No,
I
that's
mean,
what I'm saying. So these guys, again, so I'm assuming it is one of the holes that they're talking about, but I don't know for sure. But I
yeah,
am assuming we have to say it has to be inline datum. If it's a
yeah,
datum hash, I don't know how
yeah,
we can like get all these values, datum.campaign ID and all of that.
yeah, because you'd have to unhash it, I
You
guess.
can't unhash it. That's the point of a hash, no?
Yeah, yeah, that's that was a joke.
Oh, see, inline datum they had.
Oh, okay.
So yeah, so they're checking for whether it's inline or not.
Yeah, when output datum is inline, then you get the Oracle datum from the inline, and then I'm able to expect and destructure that from it. So I
Yeah.
expect the type of Oracle datum, right? So you just do
Yes.
inline first, and then you can do the actual type. Ours is backer datum, right? So
So instead, so how come, so can we not directly use this like this instead of using when?
yeah, sure. I don't care. I was just writing it.
Yeah, because the moment you say when, it'll start giving you like little branches. So we'll have to like get into the right branch and all of that.
Mm.
I thought that's what we were going with because we have two different branches of datum.
So we are just checking for one type of datum here. We don't need to check both branches here because this is only refund, remember? We have already done the branching here, 1, 2, 3. And for the rest of
Oh,
them,
you're absolutely right. Yeah. We already have. Yeah, you're right. We're expecting. So then it's not some. It would be backer datum, right?
yeah, it has to be backer datum. Um, um, no, we are giving so it'll still be some because it'll still be optional backer datum. It'll be optional datum, optional data, right? Unless we do this expect part up here in the validator, which we didn't.
Yeah. I don't know. I'm guessing this is going to throw an error, but I don't know why. I just am guessing that.
No, so I would still think this will be option data. And then, so instead of this, we can like do it in 2 lines, which is we call this datum. And we say, expect inline datum equal to datum. And now we have the new datum. We have unwrapped it. And then we can say expect backer datum and this one, not unwrapped datum. Yeah, okay, fine. If it's unwrapped, yeah. So this is how I'm assuming it would be. But does anyone have any ideas? Huh?
No, that's what I would want to see as well. That seems clean to me. Sum datum, and now I understand why you were putting the sum in there before, and maybe that would have worked. I see it now, but that looks clean to me.
You should change the datum we're passing in the spend validator.
What was that?
Change in the spend validator.
I changed it to data right here.
Yeah, but you should. But here, like the expect sum, should that be there? Because that changes it from option to something else.
So I changed it here. Where is where? Oh, here, right?
48,
here is what
yeah.
you're saying. Yeah. So I am saying we should remove this. You're right. We should remove this and then check in each of these branches.
Right.
Okay.
Yeah.
Is that cleaner, or do you want to do it in one?
How can we do it in one though? Because if we have 2 types of datum, then we can't do it in one.
Yeah, we can pass the.
Oh, you'll say when datum is this or when datum is that, and then change the branches itself, right?
Yeah, you go to line 142.
Oh, line 142.
You don't have to.
142 is one.
There I am.
Yeah.
Right. I think this stuff could be happening before, and then we have an unwrapped datum, and then inside of the functions we expect the specific type from the unwrapped datum.
Oh yeah. That makes sense.
So in that case, we go back up here and we say when.
Oops, sorry.
Oh shit! What happened?
I fucked that up.
Oh, both of us wrote at the same time. Okay.
Yeah.
Oh yes, these 2 lines can. Yeah, that's right. That's right. This so that we don't have to repeat them because they are the same. Yeah. That makes sense. Yeah.
And now we have our sum and our inline datum checked once, not repeating the logic. And then each one would, we probably want these as data.
I'm gonna follow you 1 second. Okay, yeah.
Is what it was before.
Yes.
Okay, CF datum now.
But now, isn't it? It could be either, and we're checking.
Yes.
There you
we'll
go.
be checking inside. Correct. You are saying expect and that type. Yeah. Yeah.
Expect CF datum.
Yeah, and all the fields or whatever fields are required.
Go ahead as datum.
Correct. I think all the fields are being, or most of the fields are being checked.
But
well, amount, backer, and current funds if you want to destructure it.
Current funds,
ID.
amount, backer, yeah.
But you don't have to do that. You could just leave it blank and it would just, or no, or you have to put in the
we're just not checking the type, but it would still, it's still kind of checking it.
It is still, you're checking the type and also getting the value of the fields in one statement.
So we could remove that and we're cool with this? Or you want to add
no,
that?
we should. Yeah.
Oh, so
I mean,
wait a
I
minute.
think
So when you do this datum.campaign, is it doing both? Is it actually, will it fail when we don't do the destructuring expect statement? Right?
It
we could test
would, yeah, I think it would. This is
it.
expecting the type and destructuring. So not destructuring is
Oh,
fine. That's the
well,
same.
no.
And so we're just not checking the type. So it
Yeah,
could
yeah.
be
So,
a different redeemer type, but as long as it has a current funds equal to 0,
uh-huh.
it would pass.
Correct. So I'm saying
Oh,
it would fail if this field doesn't exist. So this is a pretty good thing. We don't have to do this anyway. Correct? That's what you're saying, no?
Yeah, it would. It needs these things anyways.
Yeah. Okay. So as long
so
as it
yeah, we don't
fails,
need
it's
that. That's
fine. Yeah.
redundant. Yeah. Because otherwise, you wouldn't need this. You could just call it campaign ID if we destructured it and everything. So yeah,
Correct.
it's fine
Correct.
as it is. Yeah, that's right.
Yeah.
Okay.
Okay. So then I would do the same thing here. Or actually, I mean, isn't it okay? Sorry, I'm probably confusing everybody, but like,
No.
should we
Well,
just keep it as that?
the only reason why because then I thought this was going to happen is that there was some instances
It gets
where
the
we're
wrong.
going to check different datum and then you're going to do something for CF datum and then something for backer datum.
Yeah.
But if you're not gonna switch it, then you just leave it.
So tell me one thing. This is like a general question. Say a function is expecting specific types of parameters and we give it a different type. Would the function immediately reject them?
If you're expecting, yeah.
I mean, like when you so for example, you have defined a function here. This is the function signature, right? It is saying datum is equal to data. So, so for example, if we take something
Oh
else
yeah.
instead of data, and if we say CF datum here, but this function is receiving datum of the type some other type, would it reject immediately? Would it like stop working, this
I
function?
think you would get a
Error, right?
build error. Yeah, if you were to write a test in
Uh-huh.
Aiken and then try build, it would error there. And then, but if you didn't have the test and you were actually able to try it with off chain, I think it would fail as well. But it's a guess.
Okay. So if that guess is correct, then here we can directly say CF datum of the type CF datum, right?
Yeah,
Yeah.
but I guess it really doesn't even matter though, right?
I don't know if it matters or not. I don't know.
Well, what's the only way to tell, Harsha?
The only way to tell what?
The
Go
truth.
test it.
Test,
Yeah.
yeah.
Test it.
That's
That's
so
the only
funny.
way.
Uh-huh.
But it is 10:46, guys.
Oh,
Yeah,
okay.
yeah. We milked it down. This is incredible. This is like one of my favorites. And I think having reading and writing. So again, we're crossing up the format, which is cool. I like working with sort of a half done, and it gets us into more like student-y kind of work because this was there was like spots where we were to do things. But I like it. Um,
So should we leave this?
I want
Actually,
to finish it.
yeah,
I
yeah.
want to
So
yeah.
like release it to the world. I mean, they gave us a half-baked string cheese